of your 7th experiment. Okay, open up your trainer kit launcher, that is DelSim. Okay, launch the trainer kit. Okay, launch it. Okay, is it visible?
Yes, ma'am.
Is the trainer kit visible? Simulation tool?
Yes, ma'am.
Yes, ma'am.
So we'll go with the what implementation of your shift register, that is using D flip-flops. So go to add IC. Okay, click on the IC base. Select dual positive edge triggered D flip-flop. Okay, so the D flip-flops we are using is dual. Dual in the sense there will be 2 D flip-flops in the IC. Fine, positive edge triggered. So we have come across what do you mean by positive edge triggered. So the state of the D flip-flop changes during the positive edge of the clock pulse. Okay, add the IC to the IC base. Okay, one IC is there. Actually, we need 4 flip-flops. So you will know 2 ICs are sufficient. But for experiment purpose, so that you can see the connections properly, I'll be taking 4 ICs. Okay, where with 1 flip-flop I'll be using from 1 IC. So I'll need 4 flip-flops. 4 ICs I need. I'll connect all the 4 ICs. Second IC being connected to the third IC base. The one more IC I will use it. Okay, one more IC I'm connecting. I'm placing on the IC base. The last one, IC base 5. Click it on. Positive edge trigger D flip-flop and IC. So 4 ICs I have placed. So in each IC, actually you have 2, but I will be using 1 so that you can view the connections properly. Fine. Okay. So the pin diagram of this as I had shown. Okay, this is a pin diagram. Is the pin diagram visible for you? Anyway, I'll pass this on. Okay, the pin diagram also, the PPT, I will pass it on for you people in Teams. You can look into it. So this is the pin diagram of 7474 IC. Okay, so please make I will be using, or we will be using the only one flip-flop for experiment purpose in one IC. Okay, that is 1, 2, 3, 4, 5. 1 is clear, that is active low. 2 is input. 3 is clock. 4 is preset. And 5 is output. 6 also is output. So we are not bothered about Q bar because it will be complement. So I'm taking only the output 5. So I'm not going to consider this, the second flip-flop, for experiment purpose. If at all you want, you can use it. Not an issue. Okay. 7 is ground and 14 is VCC. So it is 14 pin IC. So remember this. Okay. We'll be connecting these. We'll be making these connections on DelSim. One is clear. Active low. Active low in the sense you should pass a high value. It will be automatically converted into 0. 0 will activate the IC. Okay. Activate the flip-flop rather. 2 is input. Once again, 3 is clock. PR means preset. Preset in the sense, if at all you pass 0 for that, automatically the flip-flop will be set to what 1, irrespective of the previous state of the flip-flop. Okay, this will study even in the theory class. Now for time being connected to 0, that connected to 1. Okay, so let us come back to the DelSim. Okay, so here. So 1 is for 7 is VCC, so 7 is ground. Connect all 7 of all the ICs to ground. Okay, so that is the first connection I'm doing. So this is ground 7. Is ground, connect of all the ICs connected to ground. 7 is ground. Okay, here also 7 is ground. Okay, so 14 is VCC. 14 means it's the 20th pin because here the base is of 20 pins. So 20th pin will be considered as 14th pin. So connect all the 20 pin to VCC. Base connections are being done. All the ICs VCC ground is connected. Okay. Now the first flip-flop, this is the first flip-flop, second, third, and fourth ICs are there. In the first IC, I'm taking one flip-flop, second IC, one more flip-flop, Okay, in third IC 1 and 4 IC 1. So 4 flip-flops we are being using. So here, so first is clear, as we had come across in the pin diagram. First is clear. So we'll connect one first pin of all the flip-flops, okay, of all the ICs to clear. Okay, so we'll go with it. One is clear, so clear should be high. So connect it to one of the input pin and keep it high. Are you getting? Connect the first pin of the first IC, that is the first flip-flop of this IC, 1 to clear. Clear means it is active low. So pass the value 1, it will be automatically converted into 0 and it will activate the IC. Similarly, 1 of second IC, connect it to clear. So I'm taking the pin number 1 of input section as clear part, clear pin. Okay. Similarly, 1 of the third IC connected to clear. Okay. So here 1 of the fourth IC connected to clear. Got? So clear has been connected of all the what flip-flops. Now coming to the second pin. Second pin is input. Input is also only one. So one input, first input goes to first flip-flop. Output of the first goes to second. Second goes to third. Third goes to fourth. So D is input to be given only for the first flip-flop. So go back to second pin. This is the first flip-flop. First pin, second pin connected to input. Input pin 9, I'm taking it to D input. Okay. So output of the first flip-flop should be given as an input. Okay, output of the first flip-flop here is 5, that is Q. Output of this should be connected to input of the second flip-flop. So what we are going here is, fifth pin is the output of the first flip-flop, connected to the input of the second flip-flop, that is pin number 2 of second IC. Okay, output of the second flip-flop, that is this, is 5. That is connected, that output is connected as input for the third flip-flop. So third flip-flop is in this IC base. So I'm connecting to the input of the third flip-flop. Output of this flip-flop, that is third flip-flop, okay, D2 is connected to input of the last flip-flop. So this is the input pin. Are you getting? Output of input of the first is given from the external input, that is input section. Output of that first flip-flop is given as an input for the second flip-flop. Output of the second flip-flop, this one, is connected to the input for the third flip-flop. Okay. Output of the third flip-flop is connected as input for the fourth flip-flop. So got the connection, input connection is being done of all the flip-flops. Okay. Output of the last flip-flop is considered as a final output connected to the output section. Got? All of you? Yes? Output was first, input for the second. Output of the second is input for the third. Output of the third, okay, is input for the fourth. Okay. Output of the fourth is nothing but the final output connected to the output section. So input output is done. So now coming to the pin number 3. Pin number 3 is clock. You can see 3 is clock. Okay. For clock, okay, take the connection, take the input coming from 0.5. So here 4 variations. This is actually the clock's clock input you're supposed to give. Okay, 10, 5, 1 and 0.5 is nothing but the frequency of the clock. So if you take 5, output will be very fast. It is very difficult to observe. 1, it is a little bit slow. 0.5, if you give, it is comparatively slower than the previous ones. You can see how the input flows in and out the output flows out. Are you getting? All of you. So this is one part of the experiment. That means I'm storing 1011 and how to circulate we'll see in the next part of it. Okay. Now coming to 3 of the second flip-flop connected to the same clock pulse. Okay. Here also 3 connected to the third clock. That is a clock pulse. Third of the fourth IC also connected to clock. All of them are connected to clock. Okay. Now coming to 4. 4 is again preset. Fourth pin again is preset. Again, it is active low. Since it is active low, connected to clear pin itself. Fourth pin connected to clear pin, which you have taken. Okay. Fourth pin, you connected to clear. Okay. Fourth pin of third IC also connected to clear. Fourth IC connected to clear. That's all. Okay. This completes the connection. Okay. Output of the first taken the input. Output of this passed as an input for the second. Second output passed as input for the third output passed as input for the fourth. So this will see if the value is being shifted. When the value is getting shifted, so we will pass it back. Okay, so to see how the values are being shifted, what we are doing is, what I'm doing here is output pin of the first, I'm connecting to output section again so that you can see the flow. Okay, I'm taking dual connection. One is connected to output, other one connected to input for the second. Similarly, output of the second flip-flop connected to the output pin. Okay, so to say, just to observe the output, how it flows. So this is the output. Okay, so this is Q0, Q1, Q2, Q3, or anything if you take. This is D0, D1, D2, D3 is output lines. So you can see the flow, how it goes, so goes from one flip-flop to another. Okay, there will be two, yeah, what output, one output connected to output section, other output have connected to input for the next flip-flop. Output of this, one connected to output section, other connected to input for the third. Similarly, output of the third flip-flop, one connection goes to output pin, other connection goes to input of the last. Okay, last IC or the last flip-flop. Output of the last flip-flop is given as an output section, output pin, so that you can see the flow. Okay, so this is this does with the connection of the circuit. Okay, now switch on the power. Here it is 1, take it high. Here it is 1, so this is ground. Switch on the power. Okay, now, so you have, make a small observation. Okay, 0 is being there, 0 is given as an input. 0 goes on switching from one flip-flop to another. From here, it goes to here. Here, it goes to this flip-flop. If at all, I'll give 1 to input. So this one gets transferred to D0. From D0, it transfers to D1. See, D1, it transfers to D2. Can make a small observe after small delay. D3, D2, it goes to D3. Okay, I mean, you have to observe a little bit. Okay, I will make it 0. Please make a small observation. I will make it 0. So what happens? It's 0. D1 to D2. From D2, it passes on to D3. Did you observe? All of you? How would the value get shifted? Yes?
Yes, ma'am.
Okay. So now we'll put in 1011, but it's very difficult here. Practically, we can do it, because if you practically how we do it here is, once we store the value, we stop the clock pulse. Here it's difficult for me to stop the clock pulse. Okay, we'll see. We'll try it. Okay. In practically, when you rig up on the circuit, we'll stop the clock pulse. Once the clock pulse has been stopped, the values get stored in the flip-flops. Whatever values was there, it will get stored in the flip-flop. Okay, then we'll remove the connection of input. This connection of input will be removed. Once stored, it will be removed. We have to remove this connection. Once stored, we'll remove this connection. That cannot be illustrated in this what delta. So make us observation, that's all. Getting? We'll try it. Okay, so practically, when we do in the lab, we'll stop the clock pulse once the value gets stored. Fine. And then we connect the output of the last flip-flop as an input for the first. Okay, the value goes on circulating for every clock pulse. That is a logic. But here it's difficult to implement. So I'm just telling you how the value gets shifted. Okay, so now I'll give 1, value gets shifted. Okay, next is 0. 0 gets shifted. Next is 1. Next is 0. Okay, so it is stored as 0101 is stored. This is what I'm able to do it. 0101 is stored in the flip-flop. Okay, now the problem with the delta sim is I cannot make reconnection here. That's a difficult part. Okay, so I will try. Yeah, I can't make it. I can't reconnect it now once we stop the pulse. You have to switch it off. Once you switch it off, whatever value is being stored, it gets stopped. Okay, can't do like the things like that. I'll try. Okay, output of the last flip-flop. Connected as input for the flip-flop. Okay. Coming is high. So it is not going to take it all. Okay. It's not going to take it at all because for this two input, for this pin number 2, we are given two input connections. From which input it will take, it will be a dilemma for that. Actually, we should remove the input, external input, and give the output of this as an input for this, which is practically not possible for me to demonstrate here. Okay, so we're not going to do that. Remove connection. This connection will remove. So we're able to store the content in the flip-flop. Once stored, practically in the lab, what we do is output of the last flip-flop you connected to the input for the first flip-flop, remove the external connection. Okay, once external connection is being removed, and then if you enable the clock pulse, the value goes on circulating in the flip-flops. So that is nothing but sequence generator. Using shift register, we are able to store the sequence, to store a sequence, and the sequence goes on circulating. Okay, and through the last output, you can extract the sequence. Are you getting? So just to give a demo of this, so this is 0, 1, 0. So we can, so 0, 1, 0, 1 is being stored. We want to store 1, 1, 0, 0. We'll see. So have, let it go off. 0, 0, 0, 0 is there. Once it goes, we'll shift it. Okay, so 1, 0, 1, 1. Yeah. So now stop the clock pulse. Once you stop the clock pulse, you can see 1, 0, 1, 1 being stored. Once you stop the clock pulse, the value gets stored in the flip-flop. Okay, now the next step is actually we should remove the connection, which is not possible for me to do it now. Okay, so this will be done in the practical, that is the demonstration class. Remove this connection, connect the output of the last IC, that is the last flip-flop, that is this, back to the input. Okay, so when you do this, this value goes on circulating. Okay, and from the last pin, you can take out the value. This is the last what IC, that is D3. From this, you can take out the value, that is 1011. After every clock pulse, you can take out the value. So this is your seventh experiment of shift register where the value gets shifted. An application of the shift register is you can generate the sequence. If at all you want to send the sequence across the network in the form of a data, this sequence generator will be useful. Okay, got an idea of this? Want me to do it once again or is it fine? Hello? Yes?
Ma'am, the last thought two, could you please repeat it, ma'am? 1011.
Okay, so last bit you want to repeat. Okay, fine. So I will switch off the power. The only thing is it depends. Whatever value you want, as soon as the value gets stored, you have to stop it. You have to stop the clock pulse here. Once you stop it, whatever value is being given, that will be stored. Once again, we'll do that once again. Okay, so fine. So this is make the clock pulse high here. Okay, or sending the input also, you can make it high. So now it is the power. Okay, so I want to give, let us make it a 0 first. Let the zeros get filled up with the flip-flop. Okay, once all the all the flip-flops get filled with 0, then I will send the value 1, 1, 0, 1. 0, 0, 0, 0. Now send 1, 0, 1, and 1. 1, okay. It's not taking, 1 second, wait. So 1 is there. Let me pass 0. 0 shifted to D0, then pass 1. 1 gets shifted to D0. D0 value gets shifted to this. Again, I'll pass 0 to D0. So you'll get 1. So it becomes 1, 0, 1, 1. Stop it. So you'll get 1, 0, 1, 1 being stored. So that depends on the way you give the input. So nothing to worry over there. Okay. So as soon as you pass it, see what is being passed there. Okay. So that value get passed on to all the flip-flops. get stored in the flip-flops and stop the clock pulse. Whichever value you want to stop it, store the value and stop the clock pulse, the value gets stored. Okay. Any other value, we'll see. Okay, so here you have the 0. Clock pulse, you set it on. Okay, so 0 is passed on. 1 I will send. 0 shifts to, see, 0 gets shifted here. 1 gets shifted to this one. 0 gets shifted to this person. Again, I'll send 1. 1 goes to D0. 0 goes to D1. Once again, I'll give 1 and stop the clock pulse. So you can store 1, 1, 0, 1. As soon as the value, you have to observe. That's the only thing. 1, 1, 0, 1 is being stored in the flip-flops. Got?
Yes, ma'am.
Yes, want me to do it once again, reconnection, or is sufficient?
Sufficient.
Yes, I'll just repeat the connections. Okay, very few connections are there, comparatively very, very few connections. And the connections are similar to one flip-flop and the other. That is one IC to the other IC. Okay, so it is the same. So nothing to worry about that. Okay, so one pin, pin number 1 of all the flip-flops connected to what? Clear. Clear should be enabled what set to 1 because it is active low. Fine. Stop it. Okay. So first pin connected to clear. Clear of all the flip-flops you connected to clear there and set that to 1. Okay. Second pin is actually the input. The first flip-flop will get input. Second flip-flop will get the input from the first flip-flop. Third flip-flop will get the input from the, that is 2. Get the input from the second flip-flop. Similarly, input for the last flip-flop will be the output of the third flip-flop. So just pass the output of this flip-flop as input for this. Output of this you pass as input for this flip-flop. Output of this again you pass an input for the fourth flip-flop. Okay. Now coming to pin number 3. Pin number 3 of all the flip-flops should be connected to clock. Okay. Connect all the third pin to clock. Okay. Clock is here 10, 5, 1 and 0.5. It is a frequency being given. Okay. 10 is very high frequency. You'll not be able to see the change at all. Are you getting? Fine. 5 is a little bit slower. 1 is still slower than 5. 0.5 is still slower. So why I chose 0.5 is you can observe the values, how it gets shifted onto the flip-flops. That is the only reason. You can try with 5 also. You can try with 1 also. Okay. Now fourth pin connected to preset. Preset and clear are active low. Connect both of the pins to clear only, to one pin. Set it as high. You can take one more input pin and set it as high. Not an issue. Fifth pin is output. For the demo purpose, I've connected the output of the first flip-flop to output pin as well as input for the second flip-flop. Similarly, output of the second flip-flop is connected to the output. It is not required. Okay, for experiment purpose, I've just connected to output pin and as well as output input for the third flip-flop. Output of the third flip-flop connected to output pin and input for the fourth flip-flop. Output of the fourth flip-flop, you don't have the next flip-flop, so connected to output pin. Actually, there should be only one output. Serial in, serial out. So this for the demo purpose, I've just taken the parallel output also. You're getting? So this is your circuit connection with respect to experiment number 7. That is sequence generator using shift register. Fine? Yes?
Yes, ma'am.
Any difficulty you have? Hello?
No, ma'am.
Okay.